Let's finish up this 1998 AP Calc AB multiple choice with no calculator. We were on number 20, so let's continue. What are all values of k for which integral from -3 to k x squared dx is equal to 0? Okay, when is the integral equal to 0? Well, that's when there's no area or the net area is 0. So when there's no area, that should immediately then you should immediately know that k is -3 is the answer, because integral from -3 to -3, that's no interval. So there's no area, so we know that -3 is one of them. Okay, so we can even cross out two of the answers already. Okay, now we don't have to actually calculate anything because you should know how x squared looks. It's a parabola, looks something like this. Okay, so -3 is somewhere over here. If we integrate to some number k is greater than -3, we're always going to be adding an area. It's always positive, so it'll never go to 0, okay? Same thing if we integrate even if we have k is less than -3, we're going to be integrating some area. But then since the limit is bigger, we put a negative sign. Okay, so it'll still be non-zero. So the only answer is this guy. So the only value is this guy, I should say. The answer is this guy. Okay, so hopefully that makes sense, because once again, when we integrate to some value k, if k is on this side, this is always a positive. We're going to be adding some positive area all the time. So it'll never be 0. Similarly, if k is on this side, we're going to be adding area still, but it'll just be a negative sign. So that's still non-zero. Okay, dy dt is ky, and k is a non-zero constant. Then y could be what? Well, this you should recognize that when the derivative of something is derivative of y with respect to t, you get back y exactly, but maybe some constant k in front. That should signal it's the exponent function. Okay, and actually, if you remember, this is the same. This is how you derive the exponential growth decay formula, okay? So without doing anything, you should know that it's in the form like c is a constant to decay t, okay? So the answer has to be B. If not, you can also just do separation of variables and you'll still get this guy, okay? So this is the c e to kt, c is 2 in this specific case, okay? The function f is given by f is x to the 4th plus x squared minus 2. On which of the following intervals is f increasing? When it asks about function increasing or decreasing, probably want to take the derivative and do the first derivative test, okay? So what's f prime? That is just 4x cubed plus 2x. Okay, we set this equal to 0. All right, let's factor 2x. So we get 2x squared plus 1. Okay. So the critical points is just x is 0. This guy, there's never a solution. Okay. So let's check. Let's do the sign test, first derivative test. When x is positive, what's f prime? Remember, this is f prime. What's the sign of f prime? When x is positive, it'll be positive. When x is negative or less than 0, well, this guy's always positive. This guy would become negative, so negative times positive is negative, okay? So we know f is increasing when x is greater than 0. The graph of f is shown in the figure above, which is the following complete graph of the derivative of f, or f prime, essentially. Okay, so one easy way to tell is, well, here is a relative max. So we know that at this point, the derivative should go from positive to negative, okay? And there's only really one answer, which is this one. You know it can't be this one either, because the rate of change of the graph is changing, or the slope of the tangent line is changing. It's not constant. So The only answer is this one otherwise, okay? Because it went from positive to negative around that area. No other graph does that besides this one, but I just argued why it can't be that. Okay. Maximum acceleration attained on the interval t between 0 and 3 by the particle whose velocity is given by this guy is. So let's find the acceleration. That's the derivative of velocity. So a of t, we just do the power rule. It'll be 3t squared for the first term. Next term would be minus 6t. Next term would be plus 12. Okay? So we know that, at least in this interval, okay, let me actually factor, maybe that could help us look at things a little better. Let's factor a 3 out, so it'll be t squared minus 2t plus 4, okay? So in this interval 0 to 3, well, actually, I could even take a derivative again, but if you kind of know how this guy looks, you can even start plugging in when like t is 0, it'll be 4 times 3, which is 12, okay? When we plug in like t is 1, it'll be 1 minus 2. Actually, the maximum acceleration. Okay, did I write this correct first of all? 3t squared minus 6t plus 12. Okay. Yeah, I did it right. Okay. So what we want to do is, let's just take the derivative of a. So a prime, so we can see when it's decreasing and increasing, okay? A prime is what? It'll be 3. We can leave that constant alone. 2t minus 2. Okay, let's set this equal to 0. So t is equal to 1 is the critical point. Okay, so let's see how the acceleration changes, is increasing or decreasing, okay? So we're only interested in between 0 to 3, because that's what it defines, okay? So between 0 and 1, let's plug in a number like half. What's the sign of a prime? That'll be negative, so it's actually decreasing. How about from 1 to 3? We can plug in a number like 2. This would be positive. So it's going to decrease, the acceleration decreases from time 0 to 1, and then increases from 1 to 3, okay? So let's just check the acceleration at here, okay? Because it's going to start at some value, and then it'll decrease, and then it'll keep increasing afterward, okay? So we just want to check if the starting acceleration is bigger than the ending acceleration, okay? The end acceleration. I can't think of the right terms right now. Okay, so let's find a of 0 and a of 3. Okay, so basically, I'm finding the absolute max. All right, so a of 0, that's just 12. A of 3, that's what? 27 minus 18 plus 12. So we know that this is some number, positive number. We add 12, this was already 12. So we know a of 3 is the biggest, okay? So the maximum acceleration would be, actually we do need the value. Okay, so what is that? That is 9 plus 12, which is 21. Okay, so once again, let me recap. It asks about the max acceleration, so we optimized acceleration. How do we get acceleration, first of all? We need to differentiate velocity, so that's what I did here. This is parallel. And then I differentiated acceleration to get a prime. Okay, I found the critical point to be t is 1 by setting the a prime equal to 0. Okay, that's what I did here. I did the sign test on a prime. So between 0 and 1, acceleration is actually decreasing. And from times 1 to 3, it's increasing. So as I was saying, we're just finding the absolute max. Okay, so we need to know if the beginning point is bigger than the endpoint. So that's what I did over here. And it turned out the endpoint is bigger, so that's the absolute max. Okay? What is the area of the region between the graphs x squared, negative x, from x is 0 to x is 2? Okay, so let me show my previous work for that. X squared, we should know how that looks. That's a parabola opening upward. Negative x, that's even easier. It's just some straight line going down, okay? So parabola, the straight line going down. And they give us the limits are 0, x is 0 and x is 2. So it's this area. Okay. How do you find area? Upper curve minus lower curve. Upper curve is x squared minus lower curve, which is negative x. And the limits of integration are from 0 to 2 because we're integrating in terms of x. Okay. So this is just x squared plus x dx. So we just do parallel. X cubed over 3 plus x squared over 2, evaluate from 0 to 2. So it becomes 8 over 3 plus 2, which is 14 over 3. Okay. The function f is continuous on the closed interval 0 to 2 and has values that are given in the table above. The equation f of x is half must have at least 2 solutions in an interval 0 to 2 if k is equal to what? Okay, this is just testing you intermediate value theorem. Okay, so let's even just sketch this out real quick if you don't remember what that theorem says. 0, comma 1 is somewhere here. 2, comma 2 is somewhere up here. Okay, and x is half is somewhere here. Okay, so basically, how can there be at least 2 solutions? Okay, so we just need some point between x is 0 and x is 2 that is below this line. Because the key is f is continuous. If there's some point below the line, then it has to cross x is half one time to get to this point, and cross again to get to this point here. It doesn't have to be a straight line, but that's just one path. It has to cross at least once. So something like this could work, or maybe this is how it is, but maybe it crossed like this to there, and then it went like that. That's fine too. Or maybe it even oscillated a few times and then went to that point and then went up to here. Oops, I didn't draw it to that point, but you get the point, okay? So the point, this k has to be below half. So the only point is 0. Okay, 2 more problems. Average value, oh, this is easy, okay? How do we find average value? That is 1 over 2 minus 0, the length of the interval. Integral across the interval, so it's 0 to 2, of the function. Okay, that's how we set up the integral. So I did the work over here. We do a substitution. U is x cubed plus 1. Du is 3x squared dx. So x squared dx, that's du over 3. Du divided by 3. And then square root u. And then we have to change the limits of integration because it's a definite integral. When x is 0, u is 1. When x is 2, u is 8 plus 1, which is 9. Okay, square u du. And so I combined this to a 6, and then I did the parallel, 2/3 u to 3/2, evaluate from 1 to 9. Okay, so this I combined into is 1/9. Oh yeah, this is 1/9. I didn't see. I wrote this as the 1. Okay. Okay. So, because this can cancel to 1, this can cancel to 3, becomes a 9. Okay. 9 to the 3/2, that is 27. How did I do that? 9 to the half, that's square root 9, which is 3. 3 cubed is 27. And then 1 to 3/2 is just 1. So this becomes 26 divided by 9. That's the answer. Okay, and is this the last problem? This is the last problem, okay? They ended with an easy last problem. F is tangent to x. F prime of 5 pi over 6 is what? Well, we need chain rule. F prime is secant squared of 2x times derivative of 2x, which is 2. We evaluate at x equals to pi over 6. Okay, so that would be, so there's a 2 from there. what is secant squared of 2x? That's just the same thing as 1 over cosine of 2 times pi over 6. That's pi over 3, that whole thing squared. So this is what? 2 over, what's cosine pi over 3? That is half. So this should be 8. Okay. And that's it for the no calculator portion. I told you it was pretty easy. All right, so please like this video if you found it helpful. And please subscribe to the channel to get notified for the video where I'll be doing the with calculator portion.